Hello everyone. Good evening. So I welcome you all to the Sri Chaitanya Education Institute, the YouTube channel right now, and we are again came with the part 2 of the physics one, the questions which we already done in the part 1, and now the continuous session with it. Okay everyone. So now again what we are doing it here. We are doing the same thing as the previous one sessions also, and that is what we are discussing the questions on the score based on for the physics. Okay, so this is Sachin sir, your physics faculty for the practice one and all. Okay, so where we are in the Sri Chaitanya Education Institution, and what we are doing again, that's the score examination preparation we are doing it. Okay, so that's why we are doing it. That's, we all know the lots of awards we have it, like 2.5 crore the cash rewards we have it, 100% scholarship we are having it, and the exciting gadgets, and the major part, one of my favorite every time I told everyone, and that is the trip to NASA. Yes, that is the one. This is the something which is very important. Okay, so the thing is how you can achieve that. You need to register first. Yes, you need to register first. So don't forget to register on the www, that is http, that is srichaitanyascore.com. okay, link will be given in the description. Everyone, so you can just check it. Okay, and the exam dates are 28th of September and 12th of October. Okay, so this is the practice session number part, that is practice session we can say, or that is the part 2 of the one which we have already started it. Yes. Now, so again, physics 1 part, and which thing that is being given here, that is the class 8 physics previous year questions, and that is a part 2. Okay, so I hope this much has been okay with everyone. Yes, so let me just check the colors and all. Okay, so here we go. So everyone's ready now? Yes, shall we start? Yes, so here we go with the question number first now on the screen. Okay, a bat can hear. So what we'll do the questions, we'll take the concept of it, formulas and everything, and put it. So the question which is being seen here, we can do that, and if the question comes related to it, we will able to do that too. Okay, clear? So we have a bat can hear the sound of frequencies up to 100 kilohertz if the speed of the sound is in air is 345 meter per second, then find the minimum wavelength of the sound which it can hear. First of all, if we are given the bat and 100 kilohertz, that is correct. Why? Because we have the frequency in the two part, that is the infrasonic, okay, then audible range, yes, and we have the ultrasonic. Okay, so this infrasonic is, that is the below 20 hertz. Okay, that is the below 20 hertz. Then we have the audible range is between 20 hertz to 20 kilohertz. Okay, and these ultrasonics are more or greater than 20 kilohertz. So obviously we can see these 100 kilohertz frequency is an ultrasonic one. Okay, clear? See, I am taking each and every part, giving you and explaining each and every part, so if the question comes related to other of the part of it, so you can easily do it. Okay, that's what we are doing it right now. Okay, so a bat can hear the sound of the frequencies up to 100 kilohertz. That means what is given to us, so let us write given here. What is given to us, 100 kilohertz is the frequency. So either you denote it with the F or with the nu, it is 100 kilohertz. Okay, but the SI unit of hertz is in, SI unit of the frequency is in hertz. So we will write 100, and that is in kilo. So 1 kilo, that means 1000. So into 10 to the power 3 hertz. So it will be 10 to the power 5 hertz. Clear? So that is the frequency which we have got it. Okay, now the speed of sound in the air is 345 meter per second. Okay, so that is the wave speed we can say. So wave speed is 345 meter per second. See, now meter per second is the SI unit of the speed we have done, then the frequency also done. Now find the minimum wavelength of the sound which it can hear. Find the minimum wavelength. Wavelength means this lambda, you have to find it out. Okay, we have to find this lambda. Now for this lambda, what we can do is, let's just change the color and write the formula of it. So we know this wave speed is equals to frequency into lambda. Okay, so if you want me to write, I can just write it down. Wave speed, okay, that is equals to frequency into wavelength. Done. Just put the values now. So we need to find this lambda. Yes, we need to find this lambda. So how we can find this lambda? Take the, so it will be like V equals to nu lambda. So lambda will be equals to V by nu. Okay, clear? That's a simple, that's a formula which we have to use it while finding the frequency or the wavelength or the speed of the sound. That is a wave speed. So just remember this thing. Whenever you have to find the frequencies, wavelength or the wave speed, you will use this formula. Okay, so if you see the question something like this, you will just use this formula. Okay, if in case the speed is not given, then there is missed values will be given, and we'll use the formulas accordingly, and we'll use that. Like suppose for example the sound is being traveling with some speed is not given, it's traveled certain distance and echo is being going on. Okay, so that is the distance is 2d, and time v has been given, so we can find out the v, and then we can put the v in this, and then we'll find it out the other values of. Okay, so this, like this we can do. Now simply just put the values here. So v is 345 upon how much it is, 10 to the power 5 hertz. Clear? The answer which is given us in the mm, that is millimeter. Okay, now see it one thing here, 1 meter is equals to 100 centimeter, 1 centimeter is equals to 10 meters, sorry 10 millimeters. Okay, so 1 meter will be equals to millimeter, which can also be written as 10 to the power 3. Okay, so we need to convert it now. This is in meter, this is in meter, and this is given in as what, in this hertz. Okay, so now let's just change the value here. I'm just writing it here, everyone. Okay, so it will be like, wait, let me just erase it, that will become very easy for you to understand. Okay, so let's erase this one. This I think already you've seen it, this part. Okay, now it's been clear. Yes, so here we go. See, so let's put the value here. So lambda equals to 345, and that's in meter now. We need to do it in millimeter, so we will multiply by 10 to the power 3 upon 10 to the power 5. So lambda will be equals to 345 into 10 to the power 3 and into 10 to the power minus 5, when this 5 goes, this 10 to the power 5 goes up in the numerator. Okay, so lambda will be, this is, the bases are same, so power will be added, minus 5 plus 3 will be equals to minus 2, so that is 345 into 10 to the power minus 2, so it becomes 3.45 mm is the wavelength. Okay, so the option number which is given to us is this one, 3.45 mm. Okay, so I hope so this is clear to everyone. Yes, this is the basic one question which has been given, but the formula which we have to use is, remember this one. Okay, for the frequency I told you it's ultrasonic. Why? Because it is greater than 20 kilohertz. It is greater than 20 kilohertz, that's why. Okay, it's greater than 20 kilohertz, so that is given to us. Meter speed is given, wavelength we have to find. Very simple. Okay, let's move to the next question now. Let's move to the next question. This one is done, ultrasonic wave and everything has been done. Okay, let's see now. A current, if a 2 ampere of current is flown through the conductor, the charge that flows in 1 minute is, so let's see here. If whenever it's talk about the current I, that is Q upon T, that is called what? So current is equals to rate of flow of charge. That's the rate of flow of charge. Simple. That's the rate of flow of charge. So rate of flow of charge is Q by T. So that is been, and this I have the SI unit is of ampere, that is a unit denoted by A, Okay, simple as that. Now if we want to find out for the Q, that is Q is equals to plus minus NE, that is called quantization of charge. Quantization of charge. Okay, and whereas the number of electrons or the protons which has been there, and this E is having the value 1.6 into 10 to the power minus 19. There is a magnitude on the charge of the electron. So these two formulas has been important, which I've already written to you all, for you all. Okay, this has been done. Now let's write the given. What is given to us? 2 ampere of current flows. So I is given 2 ampere. Okay, the name of the scientist who found out given this term and ampere is Andrew Mary Ampere. Okay, remember it. Clear? Now current flows through the conductor. In a conductor the current has been flowing. Suppose this is a conductor, and in this conductor the current has been flowing like this. Okay, so that flows in 1 minute. So time period is given in 1 minute. Now we all know, see, every time in the numericals what we have to do, we have to see it, the things is being given in SI unit or not. Ampere is in SI unit, and it's a fundamental quantity also. The time is 1 minute. We need to convert it into seconds. So 1 divided by 60. This we will do. Tell me, you will do this? No. That's a 1 minute na. So we don't have to convert into the hours. We need to convert it into the seconds. So 1 minute is equals to 60 seconds. That is multiply by 60. Okay, don't do this mistake. See, I know most of you don't do it, but I have seen some of the students what they basically do, divide by 60. That is for the hour which you have to do. Okay, that is for the condition of the hours when you need to convert it in the hours. Okay, clear? Here we go. See, so charge we have to find. So that's I is equals to Q by T. So Q is equals to IT. Now it's been saying this been given in C, so let's write in there of C, that is equals to C, and I is how much? That is 2, and this is how much? 60. So that will be like 120 coulombs. Okay, so either you write it this or write it this. Q is equals to 120 coulombs. That is 120 coulombs. Clear? Okay. Clear? So this is the basic thing. So this is the formula which we need to remember again for the charge and all. And one is for this one, that is called the quantization of charge, where you can find the number of electrons. Okay, this we can do. So it's the easy one, and that's the unit is coulombs. That unit is coulomb. Okay, time we know seconds, I is ampere, and that is a coulomb unit. Okay, clear? Let's go to the question number 3 now. Clear? Okay, so here comes, choose the correct statement about friction. Very easy. Here comes the friction one part. Yes, what is this friction? If we have the relative motion, like suppose, see, if I have this my hand here, and this, we all know it, but then also see, if I just try to rub these hand on the both of it, and see, right now it's been rough surface. Okay, so what will be happening? This has been getting rubbing with each other, and if I rub it very fast, so what will happen? Because of the friction, it starts to generate the heat. So friction involves the heat. Now how can I reduce this heat? So for this, in the machines also it happens in the gears and everything. So how do we remove it? By using some lubricant. Like instead of it, I have some moisturizer in my hand and then I rub it. Then the heat generation will become lesser. Why is it so? Because friction will become lesser. Actually what is happening in the friction, we all know, every surface which seems to be very smooth are having some irregularities, okay, are having some irregularities. Suppose this is the one, and let's say another object is also having certain irregularities like this, and this is object 2. When these two objects are being like, see, suppose this my finger knuckles are been there, and see, if I just do it, it will just break. But if I do is, that becomes softer. Softer means the plane surface. So these are the microscopic level irregularities which just got clinged or just get attached to it, due to which we get the friction of it. Okay, that is one of the reason. That is one of the reason which we get it. How this friction comes? So the friction may be because of the motion. Like suppose if we are walking also, in that the friction is helping us to walk. Simple is that. Okay. So if the body is in motion, suppose the body is moving in there. Suppose like this is the one. The box has been here, and the amount of the force with the actual force we are keeping it here this side. So obviously the friction will be in the opposite direction of it. That is the friction in the moving one part, motion one part. That is okay. So there is a relative motion between the surface, that is the ground, and between the box, that is okay. Now if the box is being just kept here, so at that time also is the friction working? Yes, at that time also the friction is been working, and that is the static friction. That is the static friction. We all know it. We all know the frictions. Yes, that is the rolling friction, static friction, sliding friction. We all know it. Yes or no? Clear? We know that is one is static, second one is sliding, then we have rolling, and one of the friction also called as like the viscous one or the fluid friction. Okay, so the formula which we basically use for the friction is, that is the F equals to mu n, sorry, not S, it's n, that is mu n. Okay, so if this is been like frictional force, okay, that is the static one, coefficient of friction, that is the coefficient of friction, it's the normal force, and that's the frictional force. See, by using this formula we can find out the numericals also, and we are going to do it in that next one part also. So how we can do that? See, suppose if this is the surface, this is the box which is being kept, so its weight is been acting W equals to mg, and according to Newton's law, what we know, for every action is equal opposite reaction. So if the box has been pushing in the downward, similar way the surface will also push in the opposite direction. That's called the reaction force or the normal force. This is called N or R, that's called to be the reaction force or normal force. Whenever you see the word normal, guys, whenever you see the word normal, understand it, it is the perpendicular force. Okay, simple. Whenever you see something like normal, that means it's a perpendicular to surface something. If it's a normal force, then it is the motion. Friction opposes relative motion or tendency of the relative motion. Friction opposes relative motion if these are no relative motion or no friction acts, or all are the correct. So right now I just told you, if the object is motion or the moving, that is the one. Okay, that is the one. Clear? And if we are saying it's the rest one part of it, if it's a rest, then also it is been acting. So that we can say the friction opposes the relative motion or the tendency of the relative motion. If it's going to just move, if we apply certain force here, and right now it's not moving because the frictional force is more for this one body. For example, okay, because static friction is self-adjusting one. Remember, the question may come from this one also part. It's self-adjusting. Okay, it will adjust itself. That is a static friction one part. Okay, so that is a static friction. Okay, so that means this option number B is the correct. Okay, clear? So if you want to just see it. Okay, let's move to the next question now. Okay, here comes a block. Okay, that is a part which I am just telling you that we have to use the formula again, same. The block of the mass 10 kg, let's underline this one, block of mass 10 kg, rest, the object is at rest on a rough horizontal surface of earth. Okay, and increasing horizontal force starts to act. That means if I'm pushing something and slowly I'm increasing it, obviously the box which is be at rest, that starts to move. So in the block, it was observed that the block starts to move when the magnitude of force is 20 Newton. That is the self-adjusting one I told you. If it is become more than that, then it starts to move. That is force is 20 Newton now. Find the coefficient of friction between the block and the ground. That means you have to find the mu now. Okay. And saying clearly, take the G values 10 meter per second square. Very easy question. So what we can do now? Just draw the diagram first. This is a box, okay, and on this box a force is been acting of 20 Newton, due to which it becomes start in motion. It comes into motion. Okay. So now the weight is also acting over it. So suppose the weight is acting like this direction, that is W equals to mg. So if the weight is acting downward, so its reaction force, that will be in the upward direction. That will be in the upward direction like this. Wait a second. That will be in the upward direction. That's called to be the normal. Okay. So can I make the equation, these both are equal and opposite. So can I say N is equals to mg? Yes or no? N is equals to mg. I have done. What I have done? Box was there. 20 Newton force has been given to it, where the box will starts to move. Weight of the box will be starting in the downward direction, acting it, because it's not horizontal plane, it's not at an inclined plane. If it's used to be an inclined plane, then we have to take the angles for it. Okay. So it will be acting downwards, and the normal, that is the reaction force, it starts to acting upward. So that will be equal to equal and opposite. That's why the box is not moving up or down. That becomes in the equilibrium or the balanced condition. That is why the balance condition is there. Box पे balance condition लग गई, box अब move नहीं करेगा, ना ऊपर ना नीचे, क्योंकि दोनों क्या कर दिए, balance कर दिए. सिर्फ वो आगे पीछे क्यों move कर रहा है, क्योंकि यहाँ पे balance force नहीं है, है ना. This we know what is the balance and balance forces are there. ठीक है, इसी को हम equilibrium state में बोल रहे हैं for this one motion, for the horizontal one. Sorry, for the vertical one. Horizontal, we have the motion. ठीक है. So that will be N equals to mg. Now let's put the values. Let's find it out. M is how much? 10 kilograms. And the G is saying take it 10. So normal force is 100 Newton. This one we have find it out. Take it done. Now what is given to us? Observe that the block starts to move when the magnitude of the force is 20 Newton. Okay. Find the coefficient of the friction between them. Simple. So that is the force which you are applying it. The force which you are applying it, that will be equals to Fs. That is the frictional force. So force will be equals to mu n. Instead of F, I have written mu n. Okay. If I want to write, I can write the static one also for this, but it's start to slide. Okay. That is the sliding one now it become. So force mu into n. So from here I have to calculate this na. So mu is equals to F by n. Simple. Mu is equals to F by n. Force is how much we got it? 20 Newton. Force is 20 and divided by 100. So it becomes mu equals to 0.2. Mu equals to 0.2. Now it do not have any unit. Remember the question may come, it do not have any unit. Why? Because at the top also it's a force, down also it's a force, Newton cancel out, so it's a unitless quantity right now. So 0.2, that is 0.2 is the coefficient of the friction which we have to calculate. Very easy question, just see it once more. Okay, clear? Hi Yashwant, hi. Okay, chalo, let's go to the next now. Another question which has been related to the block one. Here we do the motion along with it. Okay. So what I have done, I have taken certain questions through which we can, or through which different type of question can come. So the major part right now is what? We need to see it. We need to see it, which formula has been working, what that question is saying. So according to this, we can solve the more question of it. Okay, again, a block of mass 2 kg, underline it, is at rest again. Suppose it is at rest, that is u is 0 initially, or don't write it. We don't know whether we have to write the u or not. Leave it. Let's read the question first. Block of mass 2 kg is at rest, okay, on a rough horizontal surface, the same line which we have studied in the previous wala. It is acted upon by constant horizontal force of 10 Newton. Theek. Let's draw it. A block has been there. Constant force of 10 Newton has been acting on it. Find the frictional force acting on the block. If now what is saying, a constant force has been acting and block is moving. So block is moving. Let's see, it's moved sometimes. How much? 18 meters around. The box moves around 18 meters from its initial position. Before that it was at rest, a constant force of 10 Newton given, he moved, or the box moved 18 meters during first 3 seconds. That is the time which has been given is the 3 seconds. In the first 3 seconds moved 18 meters. So initially the body is at rest. We will requiring it. We are requiring. Why? See now. We want the frictional force. We want the frictional force. The total force has been acting is how much? Constant. Where it has been written here. Horizontal. So net force has been acting 10 Newton. Clear. We need to find the frictional force. Okay. How much force that block has been acting? Because it's been moving now. That is, it starts to move. That's the constant net force has been there. How much force has been acting? Because that is the net force, that is the frictional force. There must be some force which has been acting, because of it it's moving. So that will be like F net is equals to F minus F. That is the horizontal force, that is the net force, and that is the F. So see, wait, F net is not given to us, beta. Just wait a second. This we have to calculate, and F horizontal is given to us 10 Newton. Only this much change. Okay? F horizontal given to us 10 Newton, F net we have to find, and that is a frictional force. So that will be the formula we can put it. Okay? Like this. If the horizontal, that is the total amount of the force which has been acting 10 Newton, minus the frictional, or if you minus the net force. So what is the net force right now acting? According to the motion. According to the motion. So that is the F will be equals to MA. Because it will be moving in the horizontal direction now. So F is equals to MA. Do you have acceleration here? No. But we can find it out. Why? How? You have U0, you have the T, you have this displacement that is 18. So UT, as you are having A, you can find it out. Out of the 3 equation of motion, that is V equals to U plus AT, S equals to UT plus half AT square, V square minus U square equals to 2AS. All these 3 equations. Let me write it down for you all so you can be given the revision. U plus AT, S equals to UT plus half AT square, V square minus U square equals to 2AS. That is the equations of motion for the constant acceleration or uniformly accelerated body. Okay? That has been given to us. Out of these we have to find the A. We have S, we have T, we have U, and we have to find the A. First one, we don't have the V, we don't have the A. We cannot use this. Second one, S we have, U we have, T we have, only A is not there, only one variable unknown, we can use this. Second one again we cannot use because we don't have V, we don't have the A. So 2 variable unknown. Told you in the previous classes also, when you are having the one unknown variable, then you can put the equation very well. And if there are 2 unknown variable, we cannot put it. Or if in condition is all 3 will not be acting or not will working, तो उस केस में हमको क्या करना पड़ेगा? 2 इक्वेशंस बनानी पड़ती हैं और दोनों इक्वेशंस को हमें फिर सॉल्व करना पड़ता है. ठीक है? I hope this much has been clear to everyone. So which one we will be using? Second. So यहाँ से हम we will write from second equation of motion, that is S equals to UT half AT square, and since the body is at rest, so this whole term will become 0. So S is how much? 18, 1 by 2 A, and time period is given 3 seconds, that will be 3 square will becomes 9. Simple. 3 square will become 9. Simple. Now let's find out the A. So for this one, A and 2 here. So 18 into 2 upon 9, that is equals to A. That goes 2 times. So A is equals to 4 meter per second square. That is the acceleration we have got. Acceleration got put into the F, that is the net force which we are taking out. So F net will be equals to, M is how much? 2 kg. 4 is the acceleration. F net is 8 Newton. Clear? F net is 8 Newton. Clear? The questions are easy. Just see it how to solve this. Okay, so 2 questions I have done. One is the simple, how the friction we have to put the formula, and second one is the little bit twisted form of it, where we will use the equation of motion and then we can use the frictional force formula. Okay, so F net we got. Now we got F net, we have FH, we have F net, so we can easily find the frictional force. Okay, so that will be like F net is how much? 8, and FH is 10 minus F. So if this F comes here and that goes there, so it becomes 2 Newton. That is the frictional force, and that's why it's been getting subtracted, because it is opposite to the direction of the motion where the force has been applied. So it's a 2 Newton. Clear? Just see it again, everyone. See it again. Okay? Clear, everyone? Chal, let's go to the next. Easy question. Very easy. But the concept will be there for the pressure. Okay? In the given question, assertion and reason are the given below. Choose the correct option. Assertion. Animals like camels walk easily in the desert as a broad feet exerts less pressure on the sandy ground. क्या बोल रहा है क्वेश्चन? कैमल जैसे एनिमल्स जो होते हैं उनके जो फीट होते हैं वो चौड़े होते हैं, बड़े होते हैं, ठीक है, ब्रॉड, एंड दे एक्सर्ट द लेस प्रेशर ऑन द ग्राउंड. हाँ ठीक है, क्योंकि जब एरिया बढ़ता है तो प्रेशर बढ़ता है. क्या ऐसा कुछ है? लेट्स सी. वी हैव द फॉर्मूला प्रेशर इज इक्वल्स टू परपेंडिकुलर फोर्स अपॉन एरिया. ऑलवेज रिमेंबर दैट्स अ परपेंडिकुलर फोर्स. सिंपल फोर्स नहीं है वो, परपेंडिकुलर लगता है फोर्स. ओके, दैट फोर्स इज परपेंडिकुलर. ओके, आई एम टेलिंग इट बोथ इंग्लिश एंड हिंदी मिक्स. ठीक है. So animals like camels walk easily in the desert as a broad feet exerts the pressure in the sandy. So here we can get this one thing, pressure is proportional to perpendicular force. यानी कि force बढ़ेगा, pressure बढ़ेगा, force कम होगा, pressure भी कम होगा. ठीक है सर. फिर एक तो ये इक्वेशन, दूसरी इक्वेशन, P is inversely proportional to area, यानी कि एरिया बढ़ेगा, प्रेशर कम होगा, एरिया कम होगा, प्रेशर बढ़ेगा. दैट्स द वाइस वर्सा ऑफ इट. सिंपल सा एक सॉन्ग बन गया है ना. सो व्हाट वी आर डूइंग इट, सो दिस इज द रिलेशन, अगेन वी गॉट इट. सो दैट इज द प्रेशर दैट इज परपेंडिकुलर फोर्स अपॉन एरिया. कैमल्स हैव ब्रॉड फीट, यानी कि एरिया बढ़ रहा है तो प्रेशर घट जाएगा. सिंपल, प्रेशर विल डिक्रीज. रीजन, प्रेशर डिक्रीजेस विद द इंक्रीज इन द सरफेस एरिया. दैट इज ट्रू. That means assertion is also true, and its reason for understanding that one is also true. So option number A, that is both assertion reasons are the correct, and reason is the correct explanation of the assertion. True, got it? If is used to be the fluid pressure, not related to this, just giving you the formula. Suppose this is a container you have. In this container, this box is being dipped or submerged into the liquid, suppose. And from the top, the atmospheric pressure, that is P naught, which value is 1.05 or 03 into 10 to the power 5 Pascal, is been there. It is been at a depth of height h. This liquid is sort of, the waters have density rho, that is called rho, a density of the liquid, density of liquid. Okay. And since it's been having its weight, so the gravity is also been acting downwards. So for these type of the pressure which we need to find out in the fluid, we have the formula, that is change in pressure is equals to H rho G, where change in pressure is P minus P naught equals to H rho G, where P is that is pressure which we have to find when the object is inside the liquid, where the object is immersed in. जब ऑब्जेक्ट उसमें डूबा होगा लिक्विड या पानी में, तब उसका प्रेशर P निकालने के लिए हमें इस P को यहाँ नॉट भेजना पड़ेगा. दैट इज द atmospheric pressure जो हमेशा लग रहा है. You must have seen the container you are having for the water dispenser, or the container you are having it, or even you can do it at your home. Take the water bottle, this normal water bottle, cold drink ones or water bottle comes na, the 20 rupee Kinley and all. Take it, okay? First drink that water, then fill it with the tap water. Don't drink it because for the experiment we want it. Okay, so just fill with the top of it and then tightly close the container. Okay, now when you just put the hole into it, you will see in the starting, because you have applied some pressure, that's why that water comes out, but after some time the water will not come, because there is nothing to apply the pressure inside it. Okay, clear? As you will just lose the cap from the top, you will see the water starts coming out from there. This happens. This is because the atmospheric pressure, this atmospheric pressure has been acting, so it becomes P naught H rho G, and that is the formula for the liquid pressure. We can find it out. Here we go, this one. Okay. Similarly, if we need to find the upthrust, so we can use the formula V rho G. that is the volume of the liquid, container or the object, density of the liquid and the gravity, and that is equals to buoyant force, or that is equals to upthrust. So these are the formulas which has been related to the pressure one part. So I have taken all of them so that if the question comes like that, you can just solve it, right? Okay, so just see it once. Here we go now. Another question. An echo returns in 3 seconds. Okay, so here comes the echo one part. You all know what is echo? The sound which we used to produce, like suppose you have seen it, in the empty room, which is a bigger one little bit, or from the mountain cliff, or in the movies, in the cartoons, if you have seen it. Okay, so it's been like, suppose if I shout hello, 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 hello. Right now it's not happening. Why? Because in the studios and all the things which we use, it is the soft material which absorbs the sound, so reflection won't occur. Okay, so after a particular period of interval of time, that is 0.1 seconds, and the distance of around 17 meters, if that happens, the sound goes, strike that particular surface, returns back to us, and this happens multiple times. So that seems to be echo. If I sound hello, 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 and slowly it will just reduce. Okay, so that is the echo. We all know it. That happens in 3 seconds. That means the sound which is going and coming back in for one time, that is 3 seconds it is taking. So time is given to us 3 seconds for the echo. Okay, what is the distance of the reflecting surface? Suppose this is the sound which has been coming, and from here the source has been there, and that is the reflecting surface. This is the reflecting surface. This is sound. Okay. So what we have to do, given that the speed of sound is 342 and the traveling speed of the sound is 342 meter per second. 342 meter per second. The sound speed is 342 meter per second. You have the speed, you have the time, only distance we have to find, and we all know the distance is equals to speed into time. This we know, but here the sound is going and coming back, and that is what the 3 seconds has been there. So if you travel the d distance, this side, so d will be returned, so total distance traveled will be 2d equals to v into t. Now one thing, whenever you see the question with the reflecting sound, हमेशा 2d equals to v into t लिख देना, खत्म, दिमाग मत लगाना, सिंपल सी बात, ठीक है. 2d equals to v into t, done. Just put it 2d equals to v into t, sufficient. Now just put the value. So what do we have to find? We have to find the distance only. So this 2d, v is how much? 342, and time is given 3 seconds. So that is d will be equals to 342 into 3 divided by 2. So that will be like how much? When you solve this one, so you will be getting 513 meters as the answer. You can try it. Okay, like suppose if I just solve it, that will be 3 2s are 6, yes, 12, 9, 10. Okay, just a second, wait. Clear? So you can just do one thing, either you multiply or divide it, whatever you wanted to do it. Like for example is 342 and multiply by 3 and divide it by 2. So let's cancel out 2 1 7 14, okay, and that will be 171, and that into 3 21 1 2 3 and 513. See, 513 is the answer. Clear? So is it just a basic calculation here. Okay, so that is in the case of the echo. That is in the case of the if the ultrasonic, if the question comes with the help of the sonar, that is the sound navigation and ranging, the sonar which use the ultrasonic waves only. So in that also the ship sends the signals and comes it, one of the that transmit the signal and receive the signal, and then we find the depth of that. We can find it with this one. If the vet is use the echolocation for find the distance for the echolocation, the question comes with the echolocation part. Use this one technique only. Clear? Clear it is? Chalo, let's go to the next. Ron placed an object at a distance of 2 meters from the plane mirror. Okay, let's draw it. So this is the plane mirror kept at the surface. This is the polished one. And Ron placed an object here. Suppose this is an object. okay, some height which is not given to us, that's an object, and it's been at 2, how much meter from it, clear? Then from the plane mirror, and we know plane mirror forms the virtual and erect images, virtual and erect. That means image will be formed behind the mirror, same size, same distance. So what is the distance between, now how much, 0.5 is being shifted away from the mirror. This is the mirror, this is the something object, now it's been moving away from the mirror, that is far away, दूर आ रहा है mirror से. So away from the mirror is how much? Suppose 0.5. So now the total length will become how much? 2.5. If the distance of an object, we know object distance, that is the property of it, object distance from mirror is equals to image distance from mirror. Okay, clear? Same as the size of an object is equal to size of an image, a virtual and erect. And one more thing, that is the another property is laterally inverted. That means right seems to be the left, left seems to be the right, and that is the name of the ambulance has been written in the opposite, so that whenever we are seeing in the vehicle from the rear view mirror, it seems to be in the correct form of the ambulance. Okay, so if it is this much, so total length is 2.5, so image form will be, so now if I want to find the image, so image will be also form here somewhere, that is also around 2.5 only. So the total distance, what is the distance between the object and the image? So this is object, this is image, so complete distance between them will be 2.5 plus 2.5 will become 5 meter. I hope so this has been clear to everyone. Yes, see it once more. These are the properties of the plane mirror, and this is how we can solve the question for this one. Okay, let's go to the next question now. So how many planets are in our solar system comes under the category of gaseous planets? See, this gaseous planets name first was coined by the giant gas planets in one of the novel of the James, the name of the some is William James something name was there in his novel, in his story he just took this name in the fictitious science fictional movie or something, it's been their story has been there, in that he has been seen. So that has been name of the giant gas planets. Okay, we all know. So these are filled with the hydrogen and helium. Okay, and the major part is how many? So we have this, the first part like the Mars, Venus, Earth, okay, Mercury, these are the terrestrial planets, and the leftover part of it like Jupiter, okay, Saturn, Uranus and Neptune. These are gaseous planets. Just remember this one part. Okay, so these are 4. They are 4. So very easy question, very easy one. Let's go to the next now. A particle moves along the circular path of radius r. Okay, so what is saying? A particle moves along the circular path of the radius r. Let's see, let's draw it one. Particle moves along the circular path of the radius r. So this is a circular motion of it. For example, this is the center. Okay, circular rate. Find the magnitude of the average velocity of a particle for the half circle if it covers the first quarter. For the half circle it's been talking about, that is, this is the half. So this is r, this is r. It's saying the first quarter circle with the speed v. First quarter means this one area, this much. This is the first quarter, and this is the second quarter. So first quarter it moves with the speed of v. Okay. Second, next quarter is moved with the speed of 2v. That is okay. Now it's asking how much, what will be the average velocity of the particle. It's been asking what is the average velocity of the particle. Okay. Let's first find out the time period of it, because see now what is the formula for average velocity, everyone? V average equals to total displacement upon total time. Now can you see the total displacement is from, suppose the body started its position from A and covering it till B, that is the half, it's a day. So radius, find the magnitude average velocity of the particle for the half circle. For the half circle, so it is A to B is the half, so that will becomes R, and R, that is the complete distance, that becomes 2R. So V average equals to 2R. But here comes the time. What is the time taken by it? So for example, the speed is different. It took time T1 and it took time T2. Clear? Nothing else we have to do. Just we have to find or calculate the T1 and T2, nothing else. T1 and T2. So what we will do? T1 is equals to distance upon speed. Distance is how much now? Now how much the distance? So it's been covering. The circumference of the circle has been 2 pi r. Okay? If I'll do the half of it, then what will become? Pi r, and half of it, that is quadrant, that is pi r by 2. So I'll write pi r upon 2, and the speed is v. So T1 becomes pi r, the small r is not there, that's the capital R. Okay, use the letters which has been given. So pi r upon 2v, that is the T1 time. Let's calculate for the T2. T2 again, that is for the quadrant. Pi r by 2 is for the quadrant. Remember, that is 45 degree. Okay. So T2, that is distance is pi r 2 only, and the velocity is 2v. That is 2v. So it becomes pi r upon 4v. So this T2 is becomes pi r upon 4v. Okay, so there is a T1 and T2. So total time will be taken what, how much? So total time will be, T total will be equals to pi r by 2v plus pi r by 4v. Take the LCM of it. Here we have taken that becomes 4v. So it becomes 2 pi r plus pi r. So it becomes, the total time will become 3 pi r by 4v. Just done. Only this much has been done. We have to put it here. Do it. So let's put this equation here. So it becomes 3 pi r by 4b. 3 pi r upon 4v will goes into the numerator. That is 4v here. Pi cancel. No, pi will not cancel out. What I'm doing. Wait. Okay. So it will be here only. That is 3 pi. So r will cancel out. Okay. So it becomes how much? 2 4s are 8. V upon 3 pi. Which is the option? 8v upon 3 pi. Here, we got it. 8v upon 3 pi. Clear? So this is the question which can come. Quadrant given to you, maybe asking for the semicircle for it, speed and everything. So we have taken the little bit more difficult question so that you can just do the easiest one if it comes. So always remember the formula and just try to find out the approach how to do it. Okay? Clear? Let's go to the next question. Done? Here we go. A farmer is moving on a square track. Okay, farmer is moving on a square track. Here we go. Suppose P, Q, R, S or A, B, C, D, whatever you want to take. A, B, C, D has been saying. Why to take P, Q, R, S? P, array, what I am doing? A, B, C, D. Okay? 60 meter with the constant speed of 2 meter. The edge length means 60 meter. That is 60, 60, 60 and 60. Okay? Speed is how much? So if suppose the boy has been here. Okay? And he has been moving in this direction with the speed of 2 meter per second. Okay? To complete the 10 rounds, the time taken by farmer to complete, time taken in completing the 10 rounds. So let's first find out the 10 rounds. Let's find out the actual distance traveled in one round. First of all, very easy. So in one complete round, it starts from A, B, C, D, A. Okay, so that will be parameter of it. That will be 4A. So 4 into 60. That will be 240 meters in one round. That is the distance traveled by the farmer in one round. Clear? In one round. Done? Finish. He has completed how many rounds? 10 rounds with the speed of 2 meter per second. Let's see. So for one round it is 240. So for the 10 rounds it will be 240 into 10. That will be 2400. that is a complete distance traveled by the farmer. Okay, that is a complete distance traveled by the farmer. So how much time he will take? So we know it, the t is equals to distance upon speed. Distance is 2400, timing is, speed is 2 meters per second, 1200, that is in second. But sir, answer is not coming, it's in minute. What I told you, lower to higher unit. So t equals to 1200 seconds divided by 60 to 0. So that will be t equals to 20 minutes. So for by the farmer it will take around 20 minutes to move. Clear? For the 10 rounds, Okay? Similar way questions can also come with the different, asking with the numbers and magnitude and all. So you can just do it like this also. Okay? Clear? Just have a look into it. Let's go to the next now. The to and fro motion of an object. Very, very easy. To and fro motion. What is this to and fro? What is this to and fro? Simple, nothing. To and fro means my hand is there working as a pendulum, and see, this is to and fro. So that is the extremities point towards the negative side, extremities point towards the positive side for me. And that is the mean point. That is the mean point. That is the central point. Like if you see the pendulum here, for example, for the pendulum, this is the bob, and the length from the top to the central part of the bob is called its effective length. Effective length. Okay. Now if this pendulum only goes here and here, so this one displacement, this is positive toward the x, negative x, and there is certain height goes, so that is the extreme point. This is also extreme. Okay, and this is the mean position. Maybe in the next class I'll be telling you about what is the kinetic and the potential energy associated with this pendulum and all. So this movement is what? To and from, to and from, to and from. That's to and from motion. To and from motion is the oscillatory. Yes, it is oscillatory, true. But circular, periodic and motion, yes, that can we say. It's a periodic also, because if you check the simple pendulum for the clock, every time it used to do with the periodic. If for particular period of time or for the particular round of the time, if it is moving like this, then it comes like this. So what is the periodic? Any motion which repeat itself at a particular interval of time, it's called to be the periodic. If it repeats itself at the particular interval of the time, is called periodic. And since it's here to and fro, so it's oscillatory also. So this type of motion is said to be the both periodic as well as the oscillatory motion. Okay, everyone, clear? So till here we will be showing these questions, then more of the questions we will be talking about in the next session. Okay, we will be discussing about the mock test, and also some of the questions I put it from the mock test itself. Okay, so we will be doing that. So again, so what we have been done, we are done with the complete with the power part 2. I have given with the some topics and everything. Okay, so do not forget to register for the score examination. That is India's one of the biggest scholarship examination. You have the chance to show your potential, to get your reward for it. And the real reward is this one, the 100% scholarship. First of all, that is a very nice thing. Then exciting gadgets you are getting, and the NASA trip, one of my favorite one, as I told you. Okay, so do not forget to register it, because the exams are coming soon for it. Okay, so please do register and do prepare it. Okay, if you have not seen the part 1, see the part 1 in the YouTube, in the playlist, go to the class 8 and then see it. Okay, do like, comment, share and subscribe, we all know. Okay, because, and just put the bell icon so it can be give you the notification when your new lecture has been coming. Okay, don't forget the exams date, that is 28th of September and 12th of October. You can register from the Sri Chaitanya score.com. dates are 28th of September and 12th of October. Okay, so it's a national level examination conducted by Sri Chaitanya. As you know, we are studying in the Sri Chaitanya Institute of Education right now, so we know it, this one part, but it's a very, very renowned scholarship examination which you can give and show your potential, and you can earn a very good rewards in it. Okay, mark my words, it is very important, guys. It is very important, not very important for the like other views, but yes, if you are going to score a good marks, you are getting the, definitely sure you are getting the very good rewards. And that is a chance to withstand, because if you are preparing for the score, you will prepare for the Olympiad and you can achieve your goal much faster, because these scholarship exams and everything will give you, help you out. Okay, so dates 28, 26, 12th is the registration, and then again the dates and all clear. So just do like, share and subscribe, and you can follow us on the Instagram, YouTube. Okay, clear everyone. On the Google Play you can download the app and all. Telegram also you can just join, and Facebook. So thank you everyone. Okay, this is Sachin sir, your physics faculty, signing off now. Okay, and good evening, and please just do these questions, go through the questions one by one, see it properly, try to solve the more questions. Okay, try to solve the more Olympiad and sort of the questions that will help you out, and please do register if you have not registered yet. Okay, so bye everyone, good evening, bye everyone, thank you.